Good evening, everyone. Myself Aditya Sharma. I am from Coachbihar Government Engineering College. Today, I am going to discuss about amplitude modulation. Amplitude modulation is a very important aspect of analog communication. So, today we are going to have our content like that. We are going through amplitude modulation, type of amplitude modulation, and frequency translation, and then we'll be going through modulation index, efficiency of amplitude modulation, application of amplitude modulation, and some numerical problems or examples. Okay, so what is amplitude modulation? So amplitude modulation is the process of increasing or enhancing the frequency and strength of the message signal. So what is the message signal? Message signal is actually the signal what we want to send from any place to the other. Okay, so along with that message signal in the modulator, we will be having a carrier signal. So what is the carrier signal? Carrier signal is the signal which carries the message signal actually. So in the modulator, the carrier signal and the message signal is multiplied, and then we will be getting a modulated signal. The modulated signal is passing through the modulator. Okay, so in the amplitude modulation, what we do, we enhance the frequency or strength of the message signal. So how we can do that? We will be multiplying the message signal with some carrier signal in the modulator. Okay, so in that process, the original signal is superimposed, and the amplitude of the carrier wave is varied with the message signal. Okay, so this is the whole process of amplitude modulation. We'll be having a message signal here, and the message signal carrier signal is multiplied in the modulator, and we'll be getting a modulated signal. Okay, so now we'll be going through the some examples. The audio signal, TV broadcasting signals, those are the very important applications or examples of that amplitude modulation. So in that part, we are seeing or we are watching a analog signal. Okay, so this is the message signal which we want to pass through. Okay, so if and now we can say that this is the message signal and this is the carrier signal. Okay, this is the carrier signal. So when these are multiplied together in the modulator, the signal becomes like that. Becomes like that. So in this case, what is this case? This is called critical modulation. In this case, the amplitude of the message signal and the amplitude of the carrier signal is same. Okay, and if we just vary it actually, then what we'll see, let's do that. So this is our message signal now. Okay, so this is the message signal, or as this is the modulated signal. So in this case, we are seeing that the amplitude of the carrier signal is greater than the amplitude of the message signal. So this portion or this phenomena is called under modulation. So now we'll be going through over modulation. So what is over modulation? Okay, so this is the phenomena of over modulation. So in over modulation, the amplitude of the carrier signal is lower than the amplitude of the message signal. So here we can see that there are some distortion in this message. So this phenomena is called crossover distortion in the over modulation. In the over modulation, we can see crossover distortion. So now coming to the types of amplitude modulation, there are three types of amplitude modulation we come across. First is single sideband modulation, second is double sideband modulation, and the third one is vestigial sideband modulation. So, in that single sideband modulation, only the one sideband of the message signal is passed through the modulator. Okay, so now it will be clear if I draw the frequency response of that signal. So this is the carrier part. This is lower side band, sorry, upper side band, and this is our lower side band. Okay, so it is having the amplitude of A M A C by 4. Okay, so in this part we can see this is the carrier part and these are the side bands. Okay, so in single sideband modulation, either this part or this part is modulated or sent. Okay, in double sideband, both these part are sent. Okay, and in vestigial sideband, a part of the a single band and a part of the second band is sent. Actually, this is a single band, later ls usb, and this is the part of usb. So this whole message is sent in the vestigial sideband modulation. Okay, so when we pass any message through the modulator, what we can see this type of signal. Okay, this type of signal. Okay, so in this part, this is the max, this is the e mean. So the amplitude of the message signal is e max plus E mean by 2. Okay, so now if we come to the time domain representation of an analog signal or AM signal, message signal, we can come across that it is AC into 1 plus MA cos omega m t into cos omega c t. Okay. So in this part, we can see that the amplitude of the modulated signal is ACAM by 4. Okay. So when we multiply both the sides, we can see SE plus ACMA AC cos omega CT, that is the carrier part of the frequency, and ACMA cos omega MT cos omega CT. So by 2 cos omega MC omega cos omega MT cos omega CT, we can write that sine 2 cos of 2 cos A cos B formula. You can remember that actually. So we will be having AC AM by 4 ACM by 4 to cos of omega mt plus cos of omega ct. So this will be the formula, and the amplitude will be ACMA by AC into AM by 4. Okay. So now what the thing is, uh, we'll be having the modulation index. So what is the modulation index? The modulation index is defined as the ratio of maximum value of message signal and the carrier signal. Okay, so the amplitude of the message, maximum amplitude of the message signal is AM, and the maximum amplitude of the carrier signal is AC. So we can see write that modulation index equal to AM by AC actually. Okay, so now coming to the efficiency part. So what is efficiency? Efficiency is the ratio of sideband power to the total power. Okay, so what is efficiency? The energy required to pass the sideband by the energy required to pass the whole signal. Okay, so now we can calculate the power of the whole message signal. Okay, so what is the total power actually, or what is the power consumption actually? So we can we have seen that st equal to AC into 1 plus ma cos of omega mt by cos of into cos of omega ct. So now we know power equal to vrms into irms. Okay, so here vrms equal to what? V0 by root 2 into 1 by r. So here the V0 equal to AC, actually the amplitude of the carrier signal, which is AC square. The result is AC square by 2R. Okay, so now AC square by 2R. And what is the power of the USB upper sideband or LSB? It is equal to AC MA by 2 whole square by 2R. So it is actually AC square MA square by 8R, and for that both of them it's equal to AC square MA square by 4R. Okay, so what is AC square by 2R? It's the power of the carrier PC. Then then the total power will be PC plus PC square, sorry, PC plus PC into MA square by 2. Okay, so now the total power is PC plus PC into MA square by 2. অতএব the total power equal to PC 1 plus MA square by 2. Now the total efficiency, what is efficiency? P of sideband by P of total. So P of sideband equal to PC MA square by 2 by PC 1 plus ma square by 2. So PC is cut and 2 is cut. The answer is ma square by 2 plus ma square. Okay. So for any m signal, the efficiency will be ma square by 2 plus ma square. Okay. So now the application. The application of any amplitude modulation is done in broadcasting and band radios. In broadcasting, we use vestigial sideband. Okay, so now we are going through some numerical example. So here we are given that the total power, find the total power of amplitude signal if the carrier power is 400 and modulation index is zero point 0.8. So from the equation we can see pt equal to pc 1 plus ms m square by 2, where pt equal to total power, pc equal to carrier power, and m is the modulation index. So PT equal to now PC 400 into 1 plus zero point 0.8 square by 2. It's actually 0.64 by 2 equal to 0.32. So now PT equal to 400 into 1 plus 0.32. So that's actually 400 into 1.32, 5.82. Today's discussion ends here. Thank you.